Welcome to the Deep Dive. Today we're jumping into the story of a company you've almost definitely heard of, NVIDIA.
hmm
Maybe from gaming, right? That graphics card working hard in your PC. But their journey is, well, much bigger than just games now. We're going to explore how they went from a small startup to, being right at the center of this whole AI boom everyone's talking about.
Absolutely. It's a really fascinating story. Lots of twists and turns, near misses, big bets. Really shows how a company can sort of navigate huge tech shifts.
Okay, so let's set the scene. It's 1993. Jurassic Park is in cinemas, showing off these mind-blowing CGI dinosaurs.
Right, that was cutting edge stuff back then.
Exactly. And in a condo somewhere, three friends, Jensen Huang, Chris Malachowski, Curtis Prime, they had this idea. They want to bring that kind of visual power, accelerated computing, they called it, to regular PCs.
Inspired by those movie effects, basically, they saw the future involved better 3D graphics on everyone's desk.
Yeah. And the name, NVIDIA. Apparently it's a mix of NV for next version and NVIDIA, the Latin word for envy. They wanted to make tech so good everyone else would be green with envy.
Okay. Ambitious from the start, and they kicked it off with just, what, $40,000?
Just $40,000. And you have to remember, back then, it wasn't obvious that you needed separate graphics hardware.
No, there was a real debate. Could the main brain of the computer, the CPU, handle everything? Or did you need specialized chips for graphics? NVIDIA bet on specialization, but they weren't alone. Lots of companies were trying to make graphics chips.
And it definitely wasn't smooth sailing. Their first big technical choice, well, it almost killed them. They decided to build their 3D graphics using shapes called quadrilaterals.
Right, four-sided shapes.
But the industry standard, driven largely by Microsoft software, DirectX, it really only supported triangles properly for 3D.
Ouch, that's a pretty fundamental mismatch.
It was huge. They were in deep trouble, nearly went bankrupt, had to lay off half their staff. Imagine facing that right out of the gate.
Yeah, talk about pressure. But, that kind of near-death experience can really forge a company's culture. It teaches you resilience, the need to adapt fast.
Definitely sounds like it did,
Well,
because they did adapt. They didn't give up. In 1997, they came out with a new chip, the RVA-128.
And crucially,
It used triangles,
Mhm.
and it was a hit, their first big success. Apparently, it saved the company when they were maybe just 30 days away from not being able to pace out.
Oh, wow. 30 days? That's cutting it fine. But that success, it must have validated their whole idea, right? That this accelerated graphics thing had legs?
Totally. And it set the stage for what came next. Fast forward just a couple of years, 1999, NVIDIA launches the GeForce 256.
Ah, the GPU.
Exactly. NVIDIA calls this the world's first official GPU graphics processing unit. They also went public that year. But this wasn't just marketing fluff. This chip was different. It was programmable.
Which was a game changer. Before that, graphics hardware was mostly fixed function. It did specific things in a specific way. Programmability meant developers could start writing custom code, shaders to control how things looked.
Right, so instead of just basic lighting, you could get much more realistic effects. Custom lighting, shadows that looked real, complex texture.
Exactly. It unlocked a whole new level of visual creativity and realism in games. A huge leap forward.
And the momentum kept building. By 2000, they scored a massive deal with Microsoft.
The original Xbox.
Yep, they became the exclusive graphics provider for the very first Xbox. Imagine the scale of that, getting their tech into millions of living rooms.
And that coincided with them really refining this idea of the programmable shader. It fundamentally changed how computer graphics were done, and we still use those principles today.
So for almost 30 years now, their GeForce brand has been huge for gamers. Hundreds of millions of people using their cards. And they expanded into Hollywood too, right? Helping render all those amazing special effects.
Yeah, speeding up the process massively for film studios. So for a long time, they were really the kings of graphics, undisputed.
But then, the story takes this really interesting turn towards something totally different, seemingly. Artificial intelligence.
And this pivot really revolves around a piece of software they released way back in 2006 called CUDA, Compute Unified Device Architecture.
CUDA, okay, so what was it exactly? It wasn't a chip.
No, it was a software toolkit, a programming model. And what it did was revolutionary. It allowed developers to tap into the massive parallel processing power of NVIDIA's GPUs for tasks other than graphics.
Okay, parallel processing. Let's break that down. You used an analogy before. like counting rice.
Yeah, think of it like this. A traditional CPU is like one very smart person trying to solve a complex problem step by step, serially. It's good at certain things.
Mm-hmm.
A GPU, especially with CUDA, is like an army of thousands of soldiers,
Yeah.
maybe less individually powerful, but all working on small parts of the problem at the same time in parallel.
Got it. So tasks that can be broken down into many small, simultaneous calculations.
GPUs became incredibly good at those, the kind of parallel math needed for realistic graphics. Turns out it's very similar to the math needed for things like scientific simulations and, crucially, for training AI models.
But did people get it right away? You said CUD came out in 2006.
Well, that's the interesting part. For about 10 years, Wall Street was deeply skeptical. They looked at NVIDIA spending all this money on CUD R&D and basically valued it at zero. They didn't see the immediate payoff.
So why did NVIDIA stick with it? What were they seeing that maybe the market wasn't?
They were likely seeing researchers, scientists starting to experiment, using CUD to accelerate complex simulations, data analysis. Stuff that used to take weeks on CPUs could suddenly run much, much faster on GPUs. They probably saw this groundswell, this potential beyond gaming.
And then came the aha moment for AI.
You could call it that. It happened around 2012. There was this big image recognition contest, ImageNet, a new type of AI model, a loop neural network called AlexNet. It ran on NVIDIA GPUs using CUDA. And it didn't just win, it crushed the competition. Its accuracy was way beyond anything seen before.
And that showed everyone.
It showed that the parallel processing power built for gaming graphics was perfect for deep learning, for training these complex AI models that learn from vast amounts of data.
That must have been a light bulb moment inside NVIDIA.
Absolutely. They recognized this wasn't just a niche thing. This new way of doing software powered by their hardware could change everything. So around a decade ago, maybe 2014, 2015, they made a really bold move.
They pivoted the whole company.
The whole company. They shifted their focus towards AI. Every new chip design started to be optimized for artificial intelligence workloads. For a company built on gaming, that was a massive, risky bet. Remember that near bankruptcy? It probably made them less afraid to make big, potentially company-saving bets later on.
A bet that, looking back now, seems incredibly prescient. It's paid off massively.
Hugely. Just look at the applications now. In healthcare, NVIDIA's AI tech is accelerating drug discovery, making DNA sequencing way faster hours instead of weeks. There was even a Guinness World Record for genomic sequencing speed using their tech, which helps save lives.
Wow. And it's not just science, right? Art, too.
Yeah, artists like Refik Anadol are using AI powered by NVIDIA to create entirely new kinds of visual experiences. And then there's the backbone of the modern internet, the data centers, the cloud.
They're powering those, too.
Every major cloud provider, Amazon, Google, Microsoft, they all rely heavily on NVIDIA GPUs for their AI services and cloud computing infrastructure.
And they made moves to strengthen that position, didn't they? Like buying Mellanox.
Right. In 2020, they paid $7 billion for Mellanox. Mellanox made high-speed networking gear.
Why was that important for AI?
Because training really big AI models like ChatGPT requires hooking together not just tens or hundreds, but often thousands of GPUs. You need incredibly fast connections between them so they can work together efficiently. Mellanox gave NVIDIA that crucial networking piece.
So they could offer the whole package, compute and networking.
Exactly. Optimize the entire system.
They did hit a snag, though, with the ARM deal falling through last year. That was a huge $40 billion attempt.
Yeah, regulators blocked that one. ARM designs the fundamental architecture for most smartphone chips and is increasingly important in data centers, too. Owning them would have given NVIDIA immense reach, but it raised major competition concerns.
But even without ARM, NVIDIA's scale today is just enormous. What, 26,000 employees? A new HQ?
Billions of their chips out there in data centers, supercomputers, workstations, self-driving car systems.
And the revenue numbers really tell the story of that pivot, don't they?
Oh, absolutely. Gaming, which used to be their bread and butter, is now, what, maybe 7% of their revenue? Something like that.
Just 7%. So where's the rest coming from?
The vast majority, maybe 90%, is now their data center segment, and that's almost entirely driven by AI demand. Their overall revenue has just exploded in the last few years.
So just to recap clearly, GPUs are good for AI because of that parallel processing. Lots of simple calculations at once.
Precisely. Training AI models involves immense amounts of matrix multiplication and other math operations that can be done in parallel. GPUs, with their thousands of cores designed for graphics, are just much, much faster and more energy efficient at that kind of work than CPUs.
And the performance increase has been staggering. You said something like 7,000 times since 2003.
Roughly, yeah. For the types of calculations critical for AI, it's an incredible rate of improvement.
And ChatGPT is the poster child for this, right? Trained and running on thousands of NVIDIA GPUs.
Exactly. It perfectly illustrates the power of combining these large language models with NVIDIA's hardware and software stack.
Which brings us to today. NVIDIA is just dominant. People are calling them the arms dealer in the AI gold rush.
That's the phrase you hear a lot. Demand is so high for their latest AI chips, there are month-long back orders. That early bet on AI, coupled with really strong technology, has given them a huge lead.
But it's not just the hardware, is it? You mentioned the software, CUDA, being key.
Critically important. CUDA is the foundation, but they've built this whole ecosystem on top of it. Software libraries like NIMS, NeMo for large language models, Omniverse for simulation. It makes it much easier for developers to actually use the hardware effectively.
So it's sticky. Harder for competitors to just offer a rival chip.
Very sticky. Developers learn CUDA, they use NVIDIA's libraries, their whole workflow is built around it. Switching costs are high. It's a powerful moat, that tight integration of hardware and software.
Plus, all the big tech companies are partnering with them.
Right. All the major cloud providers offer NVIDIA instances. Tech suppliers build NVIDIA into their systems. It creates these strong network effects. The more people use NVIDIA, the more valuable the platform becomes.
Okay, but no company stays on top forever without challenges. What are the potential headwinds for NVIDIA?
Well, several things. One is manufacturing dependence. Their most advanced chips are made by TSMC in Taiwan.
Geopolitical risk there.
Yeah.
U.S.-China tensions.
Exactly. Supply chain disruption is a concern. Then there's competition. AMD is getting much stronger in GPUs and AI. Intel is trying hard. Plus, you have Google, Amazon, Microsoft designing their own custom AI chips, and a whole bunch of well-funded AI chip startups.
So the competition is definitely heating up.
No question. And there's also the question of market saturation. Will the demand for AI training hardware continue at this explosive pace forever? Or will it eventually slow down as models become more efficient, or the focus shifts more to running AI models inference rather than just training them?
And their own focus keeps evolving too, right?
Yeah.
Gaming isn't the main driver anymore, but AI advancements are actually feeding back into gaming tech.
Yeah, that's a nice synergy. Techniques developed for AI, especially around things like neural rendering, are helping improve graphics features like ray tracing their RTX technologies.
Yeah.
So gaming still benefits.
And they're not just sticking to GPUs. They launch their own CPU.
Right. The Grace CPU, designed specifically for data centers and AI, often paired with their GPUs. It shows they want to provide the whole computing platform, not just the accelerator.
Looking even further out, they talk a lot about Omniverse. What's the big idea there?
Omniverse is their platform for building and simulating virtual worlds or digital twins. Think integrating 3D graphics, AI, physics simulation, robotics, all in one shared virtual space.
For what kinds of uses?
Oh, tons. Designing factories, training robots, developing autonomous vehicles, creating virtual content, scientific simulation. They see it as a foundational platform for the next era of computing, with hundreds of companies already using it.
And they're also heavily involved in autonomous vehicles with NVIDIA Drive and robotics with Isaac.
Yeah, pushing AI out into the physical world. It's all part of this broad vision powered by accelerated computing and AI.
So when you look at the whole arc, from that condo in '93, the near bankruptcy, the pivot to GPUs, then the massive bet on AI, it really is a story of resilience, isn't it?
Incredible resilience and adaptability. They weren't afraid to make huge, potentially scary bets based on where they saw technology heading. That history suggests they're well equipped to handle future shifts, though the challenges are definitely significant.
Right. So wrapping this up, NVIDIA's journey is pretty extraordinary. From a tiny startup focused on making games look better to becoming this linchpin of the global AI revolution, it involved those bold bets, surviving near failure, game-changing tech like the GPU and CUA, and that huge company-wide shift to AI.
It's a classic yet unique Silicon Valley story. A great example of how a company can not just ride a technological wave, but actually help create it.
It really makes you wonder, though, given how dominant NVIDIA is now and how fast AI is moving, what's the next big disruption, the next unexpected shift that could change the game again?
That is the multi-trillion-dollar question, isn't it?
What role will companies like NVIDIA play then, and what completely new challenges might they or someone else face? Something to think about.
Definitely food for thought. The tech landscape never stands still for long. NVIDIA's story is still being written.
Absolutely. Well, thanks for joining us for this deep dive into the NVIDIA story. We hope it gave you some insight into this incredibly influential company and the really powerful forces shaping our future.